Alright, so we're concerned about number 39 because we ended up with a cubic, so let's figure this out. So what should we start with? Yeah, we've got to factor the bottoms so we can find the common bottom. Don't start with anything else. You have to do that, right? So if I factor the bottoms, see, I'll get x squared over
X plus 1, x minus 2.
x plus 1 times x minus 2. Yep, cool. And that's going to equal 2x over
X minus 2, x plus 3.
cool. X minus 2 and x plus 3. All right, so what's your common bottom?
X plus 1, x minus
Oop.
2.
Wrong color.
Yeah.
Okay, so you look at this and you think to yourself, common bottom is x plus 1, x minus 2,
X
and
plus 3.
x plus 3. Okay? Now what?
Cancel some stuff.
Okay, so I'm going to multiply the whole thing through by that stuff, right?
So
And I'm going to get what?
X squared.
So multiply by common bottom and cancel. I'm going to get x squared times
X plus 3.
x plus 3. You guys all with that?
yeah.
Right, that's the shortcut. I'm saying, what's this thing missing on the bottom? Because that's what's going to end up in the top. And I'm going to get
Equals
that equals 2x
times x plus 1.
times x plus 1.
Yeah.
Okay, then what?
Or I mean,
Distribute.
Yeah, distribute. Okay, so if I distribute, I'm going to get x cubed plus 3. Oops, that was supposed to be a new 2. Plus 3 x squared is 2x squared plus 2x. You did this just so I could draw lots of 2's. Okay, now what?
New 2. Practice, practice.
Everything's so
Yeah, get all this stuff to which side do you want it
the
on?
last because you'll have 2 positive. You'll have x cubed positive and then your x squared will be positive.
Yes.
Okay, sure. So I'm going to subtract 2x squared and subtract 2x.
Okay.
So on the left-hand side here, I'm going to get x cubed
plus x squared.
plus x squared minus 2x equals 0, right?
Oh, and then you factor
And then now we see what we do with the cube, eh? There-
next out.
Is that really all it took was me saying, and then we? Okay. So on test, if you need me to walk by and say, and then we, I can totally do that. That's a hint I'm always going to be willing to give you. So we factored x out.
Oh, you're brilliant!
What are we left with?
X squared
X squared plus x
Minus 2.
minus 2.
Oh, I see.
Okay, and then we can factor that bit, right?
I know. Yes.
So I've got x times,
Well, you don't need to. Oh, no.
just kidding.
I thought it was the same as order, so.
Oh, yeah, it's not. So
X
it's almost the same though, right?
minus with the sign.
Yeah, really the signs should just
Cannot
switch
be
spots. So this should be x plus 2 and x minus 1.
Yeah.
Because we factored something that looked almost like that before, right?
Yeah.
But this had a minus sign in the middle and this one has a plus sign in the middle.
Oh, yeah.
Okay.
That threw me off. I did the other way.
So this sign should switch, but whatever. Yeah, full-blown factor this from the beginning if you need to. Whatever. So now what?
Zero product rule.
Yeah, now slap them all equal to 0, right? So 0 product rule. So you should get
X equals 0.
x is 0 or
X is negative 2.
x is negative 2 or
X is 1.
x is 1. Very nice. Okay, now what?
Check
Plug
it.
it back and make sure that the common.
Really?
Yeah.
Yeah, so I should go worry about my things, right? So where am I worried, what numbers am I worried about on each of these?
We've got 2, -1.
2, -1,
Negative
and
three.
Negative.
-3.
None of this.
So
None of this.
Close.
Yeah.
why aren't you worried?
Those will work.
The signs are
You won't get
different.
0.
Yeah, because the signs are different, right? Keep in mind, for these to be a problem, right, they have to be exactly those things. Another way you could check that is you can look here, right? Before you apply the zero product rule, you can wonder, are any of these factors part of my common bottom? If they are, that's going to cause you a headache. If they aren't, like these guys aren't, right? They're off by a sign. So we're okay.
0 comes 2.
Good to know.
But if you had your 0, it'd be like 0 minus 2.
Questions, things?
Kind of. Can you divide the top one, but the second one by x? Just get rid of one x on both sides and just simplify the whole thing?
Sure. Yeah, from right here, you guys see that? All the terms have an x in it, so we could divide this equation by x, right?
Mm-hmm.
We maybe,
And then you're left with the 1x from the cube. Or no.
yeah, so if we divide both sides here by x, we'll be left with this in
Right.
the end.
Okay.
And we'll only get 2 of our answers, right? Where'd the other one go?
Still there.
We should have worried about dividing by x because x could be 0. You guys see that? So when you
Which it
divide
was.
by a variable, you better worry about what if that thing's 0.
Okay.
So that would give you a thing that you should run back to the beginning and check.
But if there's variables in every number, can we just assume it could be 0 and plug that in instantly?
Yeah, sure. You could note, right, from here, 0 is a solution. Okay, I'm going to disregard that and divide by it, but I need that solution over here still somehow.
Okay.
So if you put that over here and then continue after you divide, that's
Good,
fine.
clear.
But it's got to go somewhere. Cool?
But they're like 2, it's basically one palabra equals another one.
Ah. So
Or
these are,
they're the different ones. Rational.
yeah, these are rational functions. So these are a little bit hard to graph. But I do know something about these guys. This guy has 2 problems, right? These are those vertical asymptote things. So this picture
Oh, okay.
has a vertical asymptote at -1 and a vertical asymptote at +2. And otherwise it probably looks something like,
Oh, right.
Ew.
this is not
So when you're
necessarily accurate, but
Setting them equal, what are those 3 points when like this where they cross?
yeah, it's exactly where this picture crosses that picture.
Okay.
Right, so the other one has problems at, I'm going to draw the other one blue. It has problems at 2 also, and at -3. Right? And I have intersections at 0, so there, -2 means it hits someplace in between these two, and 1. Yeah, total blue. So my picture might look something like this.
Just no more.
Oops, crap, that's not the vertical asymptote.
There's no
for
reason
that.
to continue this.
That's like 12 parabolas.
Oh, God.
Oop, crap, it can't hit there. So maybe it looks like this.
My brain.
Are you
Does
just
this make
drawing
sense?
I know, he's
arrows
just
now?
like drawing lines
Is there even a method?
In the middle of his head, he's like.
Yeah, there is a
"This
method.
real."
So the method is this.
Oh, wait, I didn't-
It's got to have vertical asymptotes at -3 and at 1. And then I know it hits in these 3 spots. So whatever it does, it's got to hit in there. The blue picture is probably wrong because they can't probably do that. But you guys okay with that?
Yeah.
It probably is not quite that complicated, but it could be. Maybe.
Put it on.
Put it on.
Yeah, without doing a bunch of calculus, I can't tell you what this picture looks like. But we could graph it. We could grab this in a graphic
No.
calculator.
No, it's okay. Well,
Or in
Yes.
Wolfram Alpha?
Yeah, Wolfram.
Yeah.
Save
Yeah.
that for a
That's
rainy
easy.
day.
Yeah, I mean, really the only problem is that I have to figure out how to type this in, right?
I can't figure out how to make it do dividing. Like I can't make it do fractions. I got it on my phone and it won't do fractions.
What's your
Put
phone?
parentheses.
Actually, there, you can do
Everywhere.
special stuff.
Yeah, so if you want to plot one of those, plot x caret 2
Did you know this?
divided by
I
parens
didn't know that.
x caret 2
Oh, that's what I'm
minus
missing.
x minus 2.
Just the parentheses.
So that'll plot the left one. That'll give you something akin to the black picture. And then if you just ask it again, plot the other one.
You might as well ask now.
Okay, I'm gonna turn the camera
Takes
off
2
and we
seconds.
can. So, which number was this?
Yep.
39.
So this was a picture for number 39. This was my conjecture at the picture,
Pretty close.
which actually is not horrible. It's a
No.
little bit bad, but the important bits, right, are that the purple function, which is our right-hand side of our equation, right, has some asymptote, and then it kind of does some weird stuff in between. And then the blue one also has some asymptote and does some weird stuff in between, right?
The asymptotes are like.
If you
And
scroll
there
the
are-
mouse over it, you can zoom in and out. Make it really. I think it'd be quick. I don't know.
Maybe
Just on
let's
my
try.
Oh,
Oh
I
God.
guess that'll do.
Oh God.
okay.
It says enlarge right there.
Yeah, there's a little enlarge.
Oh. Well, I did something else.
Alright.
Did it
Yeah.
work?
Yeah.
Yeah. Great.
Yeah.
Okay, so these are
Yeah.
the spots where we found, right?
Where?
These are the intersections. But what did we actually get? We didn't get points. We got we got x values, right? So we know that these guys are at 0, comma something. What was our other answers?
Or 2?
Negative
-2
2
and 1 and 0.
Okay, so we've got one at 0, comma something, one at 1, comma something, and one at -2, comma something.
How does it
U2s.
find the y value?
Well, you can plug it
Good
in.
question. What do we do?
Plug it in.
Function.
Yeah, plug it into either of the functions, right?
And then it finds all the y
So if
value.
I plug 0 in here, what do I get? I get 0 squared over 0 minus 0 minus 2 is
0,
Negative
2.
1.
0 over something is 0.
Oh.
So this point is 0, comma 0. Oh, hey, look, it actually is, right? 0, comma 0. Remember, these are input, comma output pairs, right?
Mm-hmm.
So being on the purple, right, means that it's an input-output pair for the purple. Being on the blue means that it's an input-output pair for the blue.
And if it's on both, then it's.
And if it's on both, then it's a spot where this thing equals that thing, right? That it's an input-output pair for both of them. You guys see that? That's a spot where the same input into both rules gives you the same output.
Why would you use these problems? Why would you need to plot them?
Yeah, why would I care?
Yeah.
Yeah.
What's
So
the- why would you care?
this is, when do two rules give the same output, right? So maybe I'm wondering, when is profit-making scheme A the same thing as profit-making scheme B?
Hey man, that sure cleared it up.
That, yeah.
Yeah, that cleared it up.
I know exactly what I want to be when I grow up now.
So-
schemer.
Maybe I have profit function A of X and profit function B of X. You guys know when shit like this happens? When you're
Profits
trying
get
to
started.
print things, or when you're trying to buy, like, I don't know, when you're trying to cater a wedding or something really stupid, right? P of A might be you can buy individual meals for people from one catering service. P of B might be they charge a flat fee and then a lower price per meal, right? So I'm wondering, how many guests do I have to have before it's cheaper to pay the fee and then get cheaper meals? Do you see that? That's sort of this idea. In maybe the most basic sense, right? This could be like, meals are $7 each. Or they're $100 to get the caterer to show up, and then they're $5 each. You see that? These are two lines, right?
Right.
These are two much more complicated functions. But life is rarely as simple as lines and is often much more horrible. Cool?
Sure.
Yeah,
Hope for
this is
the
fine.
future.
This is fine.
Thought I was coming to math.